In this video, we are going to be continuing our image reflections in mirrors, except in this time, we're going to be looking at the phenomena that happen when we have a curved mirror, which make things a lot more fun and interesting. So, in today's lesson specifically, we are going to be looking at concave reflective surfaces. Now, if I look at the word concave, there's the word cave in it. So think of it as our EMR, or our light, is entering a cave mirror, and it's reflecting in there. So look at the word cave, so that means it's going inward. Okay, so it makes a cave shape. Well, let's take a look here. Before we get on, we must go over some basic terms. So first of all, we have my principal axis. My principal axis is an imaginary line drawn through the vertex perpendicular to the surface. So this right here is my principal axis. It's this imaginary line. It goes straight to the vertex, and it's perpendicular to the surface at that point. Next, I have my center. So my center doesn't mean it's the center between the principal axis and the vertex. No, the center means it is in the center of this cave. So if this curved concave mirror here made a complete circle, this would be the center of that circle. Okay? Which, in other words, you might say is the radius of this circle, if the mirror made a complete circle. My next definition is going to be the vertex. The vertex is the geometric center of the curved surface. So right here's my vertex, the geometric center of the curved surface. Then we have my radius. My radius is the distance from the vertex to the center of the curve. And then lastly, we have my focal distance here. Now my focal distance is half the distance from the vertex to the center. Okay? Now the focal length is a very important thing, which we'll find out a bit later. So, now we're going to learn how we draw these and how to make these images and how they work. So right here I have an object. But first of all, we need to look at three rays here. So let's look at my very first ray. So the first ray is called my incident ray. It travels from a point on the object parallel to the principal axis. Any ray that is parallel to the principal axis will reflect through the focal point on converging mirror or appear to have originated at the focal point on the diverging mirror. So, what does that mean? Well, this is essentially what my first ray is. Ray 1 goes from my object out, and then once we hit my mirror, we're now going to draw it to the focal point. Okay? So it's parallel to my principal axis, then it hits my mirror, and we have to then draw a line to the focal point, and we're going to continue it. Now we're going to look at ray 2. So ray 2 travels from a point on the object towards the focal point. Any ray that passes through the focal point on a converging mirror is directed at the focal point on a diverging mirror, will be reflected back in the parallel principal axis. So what does that mean? So let's take a look at this. There's ray 2. What does that mean? So I go right here. Ray 2, it goes from my object, the same spot, and it goes through the focal point, hits the mirror, and then comes back. Now we have an intersection here, and that intersection is very important. So now we're going to have to do my last ray, which is ray 3, which is incident ray 3. Travels from a point on the object towards the center of the curvature. Any ray that passes through the center of the curvature on a converging mirror or is directed at the center of the curvature on a diverging mirror will be reflected directly back along the incident path. At the incident angle, must this light ray hit the mirror in order to be reflected straight back along the original path. So what does that mean? So this is my ray 3. I go from the object through to the center. And if we look at this, they all intersect, all my three rays intersect at the same point. So 2 rays is good, but we might have made a mistake on one of them, so that's why it's good to have a third ray. Now, if not all 3 of them line up at a point, then I know I might have made a mistake somewhere along the line with one of my rays. So then I have my new object now, and my object looks like this. So here is my image. Now what is this image? That's interesting. Look which side of the plane it's on. It's on the same plane as of my object, which means this is going to have to be a real image. But there's more parts of it. So if we look back from what we learned the day before here, it is upside down. So it's not erect. It is going to be inverted. What else we know about this image is that it is smaller, so it is a reduction. It is not enlargement, it is a reduction. So now you have 4 here to try. I want you guys to copy these down, pause the video, copy these down, these 4 objects that we have here, 1, 2, 3, and 4, and try and see if you could describe their images. Will they be the same size, enlarged or diminished? Will they be inverted or erect? And will they be virtual or real? So I want you to pause the video now and try these on your own. Okay, let's see how you did. So here is my first one. So my object is behind the center. So we go across, we go down, and it hits there, and there's going to be my image. So in this case, my image is, it's down here, it's going to be inverted, and it's going to be diminished. Okay, so it's going to be inverted and diminished. And this is also going to be a real image. Let's try the second one. So here, looking at my second one, it's right on the center. So when we go on the center, we do our 2 rays, and my image looks something like that. So it's actually going to be the same size, it is inverted, and it is also real because it's on the same plane. Now let's check my third one. So this is for number 3. We have an which is in between the center and the focal point. Here, we look at it, we do my 2 rays, and if we did my third, we could do the third as well, and we get my image is over here. It's actually farther away, my image looks, so it's going to be farther away. It is enlarged, and it's going to be real, and it is also inverted. So here is my last and tricky one. It's when my image is in between the focal point and the vertex. So this is the one case where it's concave mirrors where we are actually going to get a virtual image. Now in this case also, it's the one case where it's also going to be erect my image. And in this case here we have an enlarged image. So here it shows my 2 rays and how they designed that image. So let's see how right you are with that one. So here's a table that may really help you understand what's happening here. So I would suggest strongly memorizing this table and going over it and using this to help you with the ray diagrams to see if you did them right or wrong.